everyone, let's see if we can get in a couple examples of eliminating the denominator and then some that are just a little more complex. All right, so as we talked about in class, it's not the fraction that's the problem, it's the denominator that most people don't favor. So if we talk about what the denominator does, we can figure out how to undo it. So we've got 1 divided by 9x plus 1 equals 4. So if I don't like the denominator 9, and that's dividing by 9, then what we're going to do is we're just going to multiply by 9 instead. Now, because this is an equation, whatever I do to one side of the equation, I also have to do to the other side of the equation. So instead of dividing by 9, let's multiply. Now, using distribution, 9 times 1 would be 9, and then 9 divided by 9 would give us back 1. So that converts to 1x. Now I've got 9 times positive 1. That gives us positive 9. On the other side of the equation, 4 times 9 makes 36. Now, although my numbers are larger, I've done exactly what I said I was going to do. I don't have a fraction anymore. So we've just eliminated that denominator, or we've just made the fraction bigger. Now, to go ahead and finish solving as we typically do, we're going to take this positive 9, move it to the other side of the equation. So then I have x equals 27. Now, I've gone ahead and put another example here with the solution, so if you want to try it, you can. 1/7 x minus 2 equals 11, and your answer should come out to x equals 91. That'll tell you whether you're doing that correctly. Now let's look at this next one. There's 2 fractions here within this second equation, but I have 3/5 and I have 1/5. Now the good thing about this is that they're both the same common denominator already, so I don't have to worry about looking for a common denominator. But again, because they are dividing by 5 in the denominator, that's what we want to make, in some sense, disappear. So instead of dividing by 5, we're going to multiply by 5. So if I do 5 times 3, that gives me 15. 15 divided by 5 gives me 5. So I have 5x. Nope, that gives me 3. If I can do my division there. 15 divided by 5 gives me 3x. Then I've got 5 times 24. This one gives me 120. Now on the right side of the equation, 5 times 4 gives me 20. 5 times 1 gives me 5. Divided by 5 in the denominator gets me back to positive 1x. Now, I want to go ahead and make sure I get all the variable terms on the same side. So I'm going to subtract 1x from this side, and then put it on the left side. That's minus 1x plus 3x. So that gives me 2x plus 120 equals 20. Subtract the 120. So that gives me 2x equals negative 100. Divide both sides by 2, and that gives me x equals negative 50. Okay. Again, I put another example here, similar, different values, and your solution come out to x equals 60, or it should come out to that. Okay. If you don't get that, make sure you bring it tomorrow so we can look at it to see what little hiccups there are. Okay, on the bottom, the example that I left for you is this first one, and I'm going to do the second one. So the first one should come out to x equals negative 1. Let me go ahead and work on mine. So first off, I choose to do distribution to eliminate those parentheses. So I have 3 times 2x will be 6x. 3 times negative 1 will be negative 3. This negative 7 is not in the parentheses, so I'm not multiplying that by 3. And on the right side, I have 6x minus 10. Now, I can combine these two. So I have 6x minus 10. And then on the right side, I also have 6 6x minus 10. Now if I look at these, I notice that they are exactly the same on the left side and the right side. I could actually stop right here, but just in case, if you added 10 to both sides, so if you got rid of this 10 and added 10, you would have 6x equals 6x. Again, the left side equals the right side. I could also stop here. Now, let's just say that I wanted to divide both sides by 6. So if I got rid of this one, divided this side by 6, I would have x equals x. So that means, again, that's true. So whenever you see that the left side equals the right side, that means that it's always going to be true. No matter what we do, it's always going to be true. I'm going to try to erase some of my notes here. Okay. So when we have that kind of thing, this is a special case, and this is called infinite solutions. There's many possible solutions. It'll always be true. Okay, that's it for this one.